12, you're going to need to be able to graph things by hand. What does that mean? Is you use your calculator to get information on it, and then you transfer it on paper, right? It's actually not that bad. It's very similar to what we've been doing before. And let me just go to the homework part, which was on page 3, the first thing here. If you looked at the key, this said wide, right? But you're like, wait a minute, this is 85, right? What's the 0 doing there? It was supposed to read 0.85. So I would just say if you called it narrow, right, then just leave it like that. I would not make any changes because it is accurate, it is consistent. But if it had been 0.85, right, this would have had to be a wide parabola. The y-intercept is still the same. The opening is still the same. So here you just watch out for, maybe I'll actually have the key up on the screen so you can, I don't know what I'm referring to. Right, so my answer, I based it on a decimal there, which didn't make it onto the paper. I already changed that on my original. But you should be putting down narrow if you're going with 85, okay? So I don't know what you would do is get rid of that 0 or just be consistent, right? So when you're studying, you know what's happening. Was there another problem on this page or was that it? Did we have problems getting the y-intercept? Because this one here was not in general form, so you had to use your calculator for that. This also was not in general form, so you have to use your calculator for that. And so I actually show here how I do it. I type that into y1, second trace 1, x is equal to 0, and I get my y-intercept there. Same with this. So notice that you might have been tempted to say, oh, it's 0, -7, but it's not, right? It's brackets means use calculator. How's that? For just a short reminder. What did I want to say? I wanted to mention the fact, right? A is always found, like even if it's in brackets like that, that is technically A right there. Okay, so we can tell these two things are obvious to us without doing anything with a calculator. Okay, so here again, where is A? A is right here, right? With sign and all. Notice that A is just the number. It's not 10.5x squared. That's not A. A is just the number in front of it, right? So it's positive, so it's up, and it'll be narrow because it's bigger than 1. Notice that this one here, if I just focus on the squared term, there's a -1 in front of it. So I know it's down because it's negative, and it's normal because it's 1, right? If I just look at the value of that coefficient, the leading coefficient, it is 1. So that is actually a normal curve. Yeah.
How is the second one with
normal? Oh, that's another good one. Because A is right here. There's technically A is right there up front with a 1. Let me point you to where I'm getting this from. It should look at both of these other forms that have a bracket, right? If you see it like this, A is still up front, and if you see it like this with 2 brackets like that, A is still at the front. Does that make sense? A is always at the front. So no matter which one of these 3, just look at, right, the value up front, and that's how you get it. So this being 1, A is right there. Maybe do this for, right? A is right there. A is right there. So the value of A is what tells me all of that. And then I asked you to answer this one, and this is a bit controversial here. So I will do your version from scratch, because I told you to do the +1 there. I actually, if I had enough class time, I would have wanted it to stay like this. I'm contemplating whether I'm going to make you erase all of that. No, you're not going to like me after that. That's okay. I'll just leave it. So to find the X-intercepts, there may be more than one. So I want you to show me the keystrokes, right? So did this one have one? I don't think this one had X-intercepts. It points up and it's no, it doesn't have. But anyways, you would go Y2, second, trace 5. And so you just go ahead and type that in, right? And so that's 4.75. One of the biggest mistakes is to forget to square that bracket, right? So you want to make sure you square it, and then graph it, and there it is. It's never touching the x-axis, right? So there are none, right? So that's what you would write down in this case, right? Never parabola does not touch the x-axis, right? That's, if you want to know why, that's why. Okay. And then for the y-intercepts, did you find the vertex first? I'm guessing you found the vertex first, so let's do that. Vertex, I need to use second, trace, and is it min or max in this case? It's the lowest point, so this is a min. Okay, so I'm going to go second, trace. I'm going to select that third option, and it says left boundary. So left of what? Of the vertex. So if you look at where my pencil is, I first need to get that cursor to show up. So as I'm going left, this is going higher. So I'm going to go to the right until I start seeing it. There it is. It's showing up. So if this is the vertex, I am to the left of it. So I hit enter. And then I want to go to the right of the vertex. I hit enter. And every time you see guess in this course and next year, hit enter. So that is a 5, okay? 4.99, that is definitely 5. And the y value is 1. So the coordinates of the vertex will be 5, 1. And my y-intercept, I cannot just look at the equation. It doesn't give me that. So I need to go second, trace 1, and I will let x be 0. Okay. Second trace 1 can be used for a lot of things, but it definitely can be used for finding the y-intercept. And I think, is this going to give you an error message if I leave it like that? I'm not sure. I'm going to try it. Second trace 1. Oh, it does give you that. It does give you the one without even seeing it. It gives you that. So I will write it down, but I need you to be able to actually make it show up on the screen, because sometimes there's a problem with that. So obviously I need to, if I know that my y-intercept is negative, or sorry, 119.75, I definitely need to increase the y max to 100 and, I don't know, 50, just to be, and there it is, right? So now you can see more of it, and it just happens to be a curve that, right, goes, the y-intercept is way up there. It could be in the thousands, it could be in the tens of thousands, it doesn't matter, just adjust accordingly. And we did expect it to be pointing up, right? So that is that. I hope that was okay activity. So let's continue now with the dreaded domain and range. That was chapter 5 of IPR. Probably not your favorite unit. Do you remember domain and range? Some of you got it, some of you are like, right? It's not as intense as IPR, but it still builds on that, okay? So domain and range of quadratic functions. This is now for non-contextual graphs, no word problems, okay? So no word problem. This is once we start dealing with word problems, I tell you that very clearly because I don't want you to review and just, oh yeah, I'm going to review domain and range and just stick with this. No, right? This will change with contextual word problems, like contextual problems, okay? So how do I know? Well, if there's no word problem attached to the equation, you know it's not a word problem, right? So domain refers to all permissible x values, right? All of x values that are allowed. And the range refers to all permissible y values. So let's go over here and write down domain on the horizontal, so the x values that are allowed, and we'll write down range on the vertical. Notice that I have these outside of the graph. Same thing here. Write down domain along the horizontal, and then write down range there. Let's also make a note of the vertex. Okay, so the vertex is right here. That is very important to us. Vertex is right there. So we've got all of that figured out. So because the parabola opens up indefinitely, right? This would continue to separate and get wider and wider indefinitely. For a no word problems attached to it, we would always say in set notation, there's two different notations. I don't know if you remember that. Set notation, you need those squiggly brackets. And this is saying x, right? All x belongs to the real numbers, meaning like all numbers are basically allowed. So all real numbers permitted. That's what that little statement is reading there. All real numbers are permitted here. Anything goes for x. And the interval notation, you're basically telling it the start and the stop. So this is what you do for the domain negative infinity. So you go from left to right, which is positive infinity. So it's an 8 sideways, okay? So negative, and notice that there are round brackets because infinity cannot be contained, right? You can't, and square brackets as if it's included. You cannot include infinity, therefore it has round brackets, okay? And trust me, we'll do a bunch of those, so you'll be quite comfortable with it. However, if you're talking range, there are two different scenarios depending on where it's pointing, okay? For set notation, when it comes to when A is positive, here A is negative, right? So you can either look at it that way, look at the value of A, or just look at the graph itself. If it's in set notation and we do it like this, Y is the only values that are allowed is values that are greater than or equal to the Y value of vertex. And you use those squiggly brackets, okay? They're the fancy ones, okay, for set notation. That is a must, okay? So maybe next to set notation to help you remember, you do those, right? Interval notation is like this. You would start with the Y value of vertex, right? That will be included, right? And then it goes up to infinity. That is not included. Okay, whenever there's infinity, you will put a round bracket there, not square brackets. And this is how what I tell my students. Domain, you always read it from left to right. So negative infinity to positive infinity. And range, you always go from the bottom up. Okay? Just like you're filling a cup, right? So for set notation, when it's like this, you would have to say that the only y values would be less than or equal to the y value of vertex. Because think about it, right? Vertex is the highest point, so the only y values allowed would have to be less than that point, right? If you look at this parabola over here, this is the lowest point, so the only y values allowed would have to be greater than that. Okay, so and then here, this goes from negative infinity to whatever the y value of vertex is. Notice that the vertex has a lot to say. Make sure you have a square bracket. Let me bring that up. And this is the nice thing. You can choose how you want to answer. Do you want to answer in set notation or do you want to answer in interval notation? The only thing is you need to know if I gave you one of these, you need to be able to read that and know what it is saying. Okay. So I will just give you a quick note here. Note, right? Smallest first. Largest second. And you're like, what does that even mean? This is what I mean. If you have 5 and -2, like let's say down the road we're looking at that and you're like, this is my domain. I will say this, domain. If you look at that, you would have to look at it and know right away this is wrong. The student made a mistake. Because which one of these two is the smallest number? Obviously negative, right? So this can't be, right? This is wrong. Okay? So I'm gonna go domain. If this, I don't know about the numbers. They might still be wrong. Like the student might have grabbed the wrong numbers, but I know for sure that if they're not in the right order, that this is wrong. Okay? So this is the correct way. Smallest first, largest second. Okay? So let's say somebody states the range like this. 7, negative infinity. Right? 7. So okay, square brackets on the number, but round brackets on the infinity. So we're kind of getting there. But which one of these two is smaller? Negative infinity, right? I hope that makes sense. So this is wrong. The correct way of stating this would be to say, well, negative infinity first, and then 7, which is the biggest number, next. That would be the correct way of stating it. So at least if you can get that part right, that's going to help you a long way already. Because sometimes students do everything right, they grab the right numbers, but they don't put them in the right order. It's still wrong. Okay, we're just picky. Math teachers, we're just picky. What can we say? So this note is referring to what I just talked about. Smallest first, largest second. Okay? And never put a square bracket on an infinity, and then you'll be fine. If there's a number, square bracket all you want. Okay? But if it's an infinity, don't square bracket. And obviously this is only the interval notation is what I'm addressing here. The set notation, I don't have any clever lines to help you out with there. All right, next. Now perhaps it might get a little bit, we'll practice this domain and range, and then we'll do the calculator, intense calculator part, okay? I want you to do this right off the bat. Put an X there, put a Y up here, arrowheads on those axes. Let's do that. I'm using Desmos to make this, and it just doesn't. If I do a screenshot of it, it just cuts everything off, right? And so we're going to do the domain for this one and the range as well. So let me zoom out here, and I want to help you out here to make sure we get this right. Let's call this graph A, and let's call this graph B, so we can distinguish between the two. And let's put our X and Y as well as the arrowheads on this as well. See, that's the only downside. If I make this handout for you, you have to do a little bit of work to make it look pretty, okay? So both graphs are there. Let's cut this into, like, if you want to kind of see it this way, this is going to be pertaining to graph A, the top part here, and the bottom part is going to be pertaining to that second graph. Okay, so I don't know what you want to do, just make sure you make some kind of division there to make that clear. All right, so now I'm going to go back, and when you're doing, especially when you're doing the range, right, you need to look at the vertex. So let's do the domain first. Because there's no word problem attached to it, set notation is done like this. X is part of, belongs to, it's like an E almost, right? And then I just put the squiggly brackets on either end. That would do it. Like, all X values are permissible. And the interval notation would be negative infinity. So this is going to be a bit pointless at times, but I still want you to know that would be the domain. Okay. Range for that first graph. We're talking about the Y value for sure, and just be careful, because if there had been any letter other than Y on the axis, we would have used that letter. But we're talking about the range, which is the vertical, and here, because it's pointing down, we would say that only the Y values that are less than or equal to, that's the Y value right there, 2.75. I'm rounding it to 2 decimals. And then you just put squiggly brackets like that. Does that make sense? If it doesn't, I will kind of put like my orange marker and just say that, right, for the range, it's essentially, it starts up here, and only values that are less than that would be allowed. Okay. And interval notation, you're going from negative infinity all the way to 2.75. You're going from negative infinity, and remember, smallest first, largest second. I know 2.75 is there somewhere, but negative infinity would be first, okay? Then let's do the second graph, and this one you can do with your eyes closed. Sorry, can't see that, right? But it's the same as before, nothing changes. Okay, so this is pointing up. So I'd be going Y is greater than or equal to whatever the Y value is of this. And do we know what it is? I didn't put it on there, but we know that this is 5, 1, right? 5, 1. So it's values that are greater than 1 in that case. Okay. And the interval notation would be from 1 to positive infinity, right? Lowest is 1, the greatest is positive infinity, and that's how you would come up with the range of that. Okay. Okay, so now that we've got that out of the way, you'll be able to practice. Maybe one more thing, sorry. If you're into highlighting, right? I would say that here the range starts there and then it goes up, right? So that's why it's like it's 1 all the way to positive infinity. Kind of just let the graph tell you which way we're going, right? So for the range, I highlighted that. Hopefully that helps you a little bit. Next. Oh boy, right? So I want to fill in one at a time. So we're going to stick with A. We're going to fill all of these things in for it. And then we're going to graph it by hand. Okay, so you're going to need a piece of loose leaf or something very shortly. And for now, let's type in this equation into our Y1. That's what I would say should be the first order of business here. Clear everything? Is this in general form? You bet, right? So I'm gonna state that right away that this is in general form. Then do I know which way it's opening without the calculator? I do know that because A is negative, so this will be opening down. And why is that? Tell yourself because A is negative. Then I'm talking about the width here. Sorry, let me try that again. The width is wide, and that's because A is between 0 and 1. Right, 0.5, just a value. The y-intercept, can I just get it off of the equation? I certainly can. It's 0c, so it's 0, negative 200. Haven't touched my calculator yet, right, to get anything out of it. Vertex, you definitely need your calculator for that. And I'm going to be specific here. I know this is pointing down, so I'm going to use second, trace, and I'm going to find a max, right? I'm going to find the highest point, so I will actually say that I'm using max. Whenever you use your calculator in this unit, you want to be telling me the keystrokes, right? This is what I typed in. So let's graph it. So that might be a challenging part to find a good window for it. So I hit graph. Oh, there was a little something right there, just a sliver. So what I do is I go zoom 6. Press zoom and then 6. It's your standard zoom. And I see a little something there. Right? And which way is it? It seems like it's going to go here somewhere, right? It's going to go like this. If I could predict, it's going to go like this. So that's when you let your intercept help you out. So I'm going to go window, and I'm going to do this slowly, okay? I will go and change my Y-min to, let's say, negative 250. Because I know that my Y-intercept is way down in the 200s. So I'm going to hit graph again. And there it is. I see more of it already, and I can predict the behavior. So I'm going to now increase my X max. And I just have a feeling that I should go 200. Oh, that was way too much. You see that? My feeling was way off. Okay, don't trust your feelings. So this is now 200 there. So I'm going to bring it down to 100. I only need to see about 100. So X max is only 100. Hit graph again. That's much better. So I'm seeing the Y-intercept. I'm seeing both legs of it. That's great. I need to see a bit more. I need to see the vertex, right? So I'm going to go back to my window and I'm going to go to Y max and change that. I don't know, plus 50 perhaps. Let's try that. Obviously, you're going to get faster at this after a while, but I'm pretending to be you, right? So I'm going to go 150 because I don't want to keep jumping. And that does the trick for me. This, I would say, is a pretty good window. If yours looks a little different, not a big deal. As long as you see it, you're in business. Okay? I will let you see my window if you want to copy that. If you want to copy those entries, negative 10, 100, negative 250, 150. That's your window. Let me do that right here on the, just down here, I'm going to go window that I've used here is negative 10, 100, negative 250, 150. Okay? That way you know this window would for sure work for this particular case. And then let's go ahead and find the vertex. Graph, second trace, I'm going to press 4 for max, and I need to go to the left. If your cursor doesn't show up, look at these coordinates, right, and bring it to you. So left would be there, enter, and then you go to the right and hit enter. Notice you see those two arrows here? As soon as you press enter, there's an arrow, right? So it's saying like it's the vertex is in between these two arrows. That's what you're telling the calculator. And so when you press enter, you get 25. No rounding really, very like it's 25, 112.5. It's a perfect scenario for you. So that's my vertex, very important, right? Axis of symmetry, anybody remember what that is? It's basically from the vertex, right? So it's an equation, x is equal to 25. It's an equation. The equation of the min or the max, and in this case it's a max, right? And the equation is y is equal to, it's given to you by the vertex as well. So the vertex gives you this, and the vertex also gives you the equation of the min or the max. It depends on which way it's pointing. X-intercepts, I let y2 equal to 0, and then I'm going to use second trace 5. Okay, second trace 5 is how I'm going to get that. Let y2 equal to 0. It equals second trace 5. And here you have to just be careful. I want to find that one first because I'm right there. So I just hit enter, enter, enter. So that is 40, 0, 40, 0. And the next one, I'm going to go second trace 5 again. Then just go closer to it, right? So just go across over the rainbow and enter, enter, enter. And that's 10, 0. Okay, and in this case, no rounding at all, but don't get too comfortable with that. That's about to change. Okay, that is definitely going to change. So then I have my domain and range. So my domain, let's do it in two formats. X would be all the real numbers because there's no word problem attached to it, or negative infinity to infinity. And my range, I will do it in two formats as well. Set notation, that's the squiggly bracket one, right? Y is, it's pointing down, so Y would have to be less than or equal to that vertex, the Y value of the vertex, which was 112.5. Let me zoom into that, because some of you are probably squinting. It's too small. That made it worse. There you go. Okay, so that's that. And then for my interval, I need to go from, right, negative infinity is the smallest, all the way to 112.5. Square bracket on the number, round bracket on the other one. How about this? I'll help you out one more time here. Think of it this way. If it's pointing that way, your negative infinity is, right? You're pointing towards negative infinity, so that should be part of your range. If you're going this way, it's pointing towards positive infinity. In that case, you'll have a positive infinity in your range, right? So maybe that will help you out a little bit deciding what needs to be done. Okay? Let's graph this thing. So grab your piece of loose leaf. And we're going to say graphs, right? Page 8 of notes. And we're going to do A first. And here's the little secret. All you need is the intercepts and the vertex, and you're in business. So my vertex, I copy it straight from my paper. My vertex is 25, 112.5. The X-Intercepts, in this case, it does have two X-Intercepts, would be 40, 0, and 10, 0. And I separate them by commas, right? And then the Y-Intercept is 0, negative 200. Slower? Okay. Slow down? Okay. No problem. Putting on the brakes. What about this part? Did you get this? Yeah. So vertex and intercepts copied over. And that's going to help me determine my scale. If you have a ruler, this would be a good time. And I'm looking at my numbers here. Look at the X values first, right? 25, 40, 10, right? So it's not too bad when you're looking at the X values, right? Look at the Y values. You have positive 112, then you have 0, 0, don't need to worry about that, and you have negative 200. So your span on the Y is more than on your X, right? So you have to be aware of that. So I just start with a vertical like that. And I'm going to go a little bit higher, like not right in the middle. I'm going to go a little bit higher because I have more of a negative span than I have a positive. And by the way, this can also be your guide, folks, right? You kind of know, right? This is a little bit more off to the right. Okay, so this is your guide. It should look like this when you're done. Okay, so I will add the X and the Y. And then I will determine my scale. So if I go up by 10 along the x-axis, I'm in business, right? So I'm going to go 10, 20, 30, 40, 50, right? I'm going to label every second one like that. So I went up to 60 there. And I will just add a few to the left, not that I need to. I'm going to go negative 20 there. The worksheet that I will assign later has grid. It's not a perfect grid, but it's a pretty decent one. So it'll save you this part. And then here, I need to be careful. I need to be able to make it all the way to negative 200. So I will just test it. Negative 50, 100, 150, 200. So that works out for me. So I'm going to make a mark there, 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 and there. This is negative 100, and this is negative 200. And then I'll just make one up here. Maybe like this. 100 is there. And the 112, I'm hoping, right? Just make the mark right there, and I'm within. That's the 112 mark, sort of, for me. And now put the points down. Just put them down. Let's do the X-intercepts, right? So there's one right there. Just make a big dot, and then make one right there. And then go where the Y-intercept is, right here at 200, should be one right there. And the X-intercept is at 25, sorry, the vertex, 25, 112. So I'm just going to kind of, again, I'm not going to have like a magnifying glass making sure you got it exactly right. If it's within the ballpark, you're in business. So my intercepts are plotted. The vertex is plotted. You don't need to label it like with the coordinates. And now watch this. I start with the vertex. I curve out a little bit and then go down. And you kind of want to do that. So that's the left leg of your parabola. Then you go back to the vertex and try to, as best as you can, go slow, copy. I'll be fine if you just do that there. You don't have to go the whole length. Would be nice, but it's not a big deal. And as long as it doesn't look like this, right? This is the vertex. It shouldn't be a V. You should be going out a little bit and then curving up, right? So go out and then curve down in this case, right? But it should be round up there. It's a hill, okay? And then last but not least, so is this one of the more complicated ones? Yeah, sort of. It has a lot of span, goes into negative 200, right? But that way you have a pretty good idea of what's happening here. Okay. All right. Trying to think here. There's a way. There's a trick that some students want to have a perfect curve. Don't worry about, like, you don't have to have it perfect, right? But this is one trick. Some students want a point here to know exactly where to go through here. And this is my trick for you. If you want that, I go y, and then y2 is equal to negative 200. Like, I will essentially graph a line, right? Because this is a negative 200 on the y-axis. So you technically should be able to find a point that's right across from it here. So you would just go second trace 5, enter, 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 and then it's 50 negative 200. That's this point right here. So if you wanted to know exactly, right, this would be it right there. I went y2 is equal to negative 200, and then I went second trace 5. That will come in handy later. To, like, right now, you shouldn't worry about it too much. Let me just zoom into that a little bit. Just make sure your equation is there. Realistically speaking, you only need 3 points to be able to make a parabola. Right? If you have, remember a straight line, you need 2. Your teachers lied to you last year. They said, oh, you need 3. You only need 2 for a line. You need 3 for a parabola. Okay? To know where it's going. All right. So I'm gonna give you some time to try one on your own. So I need you to go back to your booklet, right? And just focus on B right now. B is not as scary. Yeah. Okay. So you go back to your booklet and do what we just did with B. Note that it's not in general form. So the y-intercept cannot just be deducted from the equation. You have to use your calculator for it. And then I want you to do the same thing, graph it, and the same thing with C. And so that's what we're doing today. I want you to try, obviously these two for sure, but I want you to go to the workbook and do pages 3 to 5. There are 4 graphs, like 4 equations with the graph they're right on that booklet. You just do it right on the booklet. So pages 3 to 5, okay, in case you can't see it. I think what I will do, if you're still struggling, do not despair. Okay, it's just a matter of practicing, and sometimes it's a little thing. I think I will make a quick video once you leave of how I got all of these values here. And I'm going to show you how I graph it. So if you want some more help with graphing, just stay put with that.